Assalamu alaikum and good evening, everyone. Uh, Today we are going to start May June 2023 paper 1-2 AS 9701 chemistry. Okay, so let's start with question number 1. When chlorine gas is analyzed in a mass spectrometer, chlorine 35 ions are detected. Which row is correct? Okay, so if it's chlorine 35 with a +1 charge, which means it has a 11 electron lesser. So normally chlorine's atomic number is 17, right? So if you see over here, they have mentioned 35. So I can find the neutrons by subtracting this 17 from 35. So I will get 18. So see here, they ask you the neutrons. So the neutrons are 18, which makes A and B are wrong ones. Is this understandable to all of you? Yes, is this clear? Okay. Now, 17 electrons, but as it has a 17 electrons, right? But when it is positive, then it means it has a 16 electrons. So if you rewrite the electronic configuration of 16 electron, it is 1s2, 2s2, 2p6. There are 10 electrons, 3s2, 12 electrons, and 3p4, right? 16 electrons are filled by 3p4. So over here, 3p6 makes D wrong. So we are left with only option C. So C is the correct answer. Is this clear? Okay. Now question number 2. Which species is a free radical? So if you recall, free radical is the one which has an unpaired electron. Any species which has an unpaired electron is called free radical. If you look at helium, if you find a periodic table, see in helium over here, it's 2, right? So if it's 2, means there are 2 electrons, which means 1 pair, right? Now have a look at beryllium. Beryllium is over here. How many electrons it has? 4 electrons in a beryllium atom. But if you look over here, it's beryllium negative. So beryllium has a 4 electron, or its atomic number is 4. So negative means 5 electrons. So 5 electron means 2 pairs and 1 electron, right? So we are getting a 1 unpaired electron over here, isn't it? So that can be our correct answer. So A is not the chance. Now have a look at C. Okay. So if you see, look at C. Okay, let me remove the previous working. So C is oxygen, right? And oxygen, it has a 8 electron and it's in group 16. So it means 6 electrons. But when it is O, 2 minus, so output means it's not 6, now it's 8 electrons. So 8 electrons means 4 pairs. So if it has a 4 pairs, which means that 8 electrons in the outermost shell, which makes it 4 pairs. So there is no unpaired electron. So C goes wrong as well. Right? Now zinc. If you look at a zinc has how many electrons in total? 30. So if there are 30 electrons, which means 15 pair of electrons. So here it is also not a single electron which is paired, which is unpaired, sorry. So D goes wrong as well. So we have identified A, C, and D wrong. So it means my correct answer is B. Is this clear to all of you? Okay. Now question number 3. Which statement is correct? Okay. The first ionization energy of chlorine is more than the first ionization energy of argon. Let's have a look at periodic table. Okay, we know about the ionization energies that The ionization energies, if you recall, okay, let me write over here. Ionization energy across the period increases and ionization energy decreases when you move down the group, right? Is this clear? So if we look at the periodic table, here is chlorine and here is argon. So argon is when we moving across the period. So it means the ionization energy of argon must be higher than the ionization energy of chlorine, isn't it? So it means that first statement is wrong. In actual, the first ionization energy of chlorine is less than the first ionization energy of argon. That is the correct statement. Is this understandable to all of you? Now, the second ionization energy of calcium is more than the second ionization energy of magnesium. Okay. So if you look at calcium and magnesium and calcium is below. So if you see over here, magnesium has two shells, right? Sorry. In a magnesium atom, there are three shells and two valence electrons. Isn't it? In a calcium atom, it is the same, the valence electron are same, but there are four shells now. So they are talking about the second ionization energy. So second ionization energy for a calcium, the electron is being removed from the fourth shell because fourth shell have two electrons. And for the second ionization energy, magnesium has a three shells because the second electron is in the third shell because it has a two valence electron. So it means that magnesium has its second electron has been removed, it's being removed from the third shell, right? And calcium second electron is being removed from the fourth shell. So which means that the calcium valence electron is further away from the nucleus. So again, this is wrong. The correct statement would be this if the less is written. So B goes wrong. Is this understandable to all of you? Yes, if any one of you has any query, please ask. The second ionization energy of sulfur is equal to the first ionization energy of phosphorus. Okay, so have a look at the periodic table. We know when we are, for example, if I draw the graph from here, this is the ionization energy of group 13 element. This is for 14 element. This is for 15 element, and after 15, it goes down like this. And then it goes up like this and this. Okay. So if you see, this is sulfur and this is phosphorus. Phosphorus is over here and sulfur is over here, isn't it? So the first ionization energy of sulfur is always is lower than the phosphorus. But see, they are on the same period. Phosphorus has 3p3 and sulfur has 3p4. But when the first electron has been removed, it becomes 3p2 and it becomes 3p3. So see, again in the same subshell and the same shell, so it doesn't affect that sulfur's ionization energy becomes higher than that of phosphorus. It still remains lower than phosphorus because initially it is lower than phosphorus. So it's not even getting equal to phosphorus. Okay, so here equal is the wrong one. The correct one, if it is written lesser or lower, so C goes wrong as well. So if C is a wrong statement, then it means our correct statement is D. Is this understandable to all of you? The eighth ionization energy of chlorine is more than the first ionization energy of neon. So it is for sure going to be, the correct one because we know that all three are the wrong one. So see the eighth electron of the chlorine, right? So it's going to be, very high energy because chlorine becomes a +7 and the eighth electron is actually being removed from, second shell. And at that moment, chlorine has a +7 oxidation number. Its nuclear charge is very high. And the first ionization energy of neon is, it's just a neutral atom. And it is also a second shell. But see, a +7 atom and its electron is being removed from second shell, and a neutral atom and its electron is removed from a second shell. So obviously its ionization energy is very big or very large as compared to the ionization energy of neon. So D is the correct answer. Now question number 4. If 1 mole of hexane combusts in excess oxygen, how many moles of products are formed? Okay, so you know the formula of hexane. It's C6H14. When it reacts with the oxygen, we will get carbon dioxide and water. So if you see, how many carbons are there? 6. So I'll put a 6. How many hydrogens are there? 14. So I'll put 7. So see, 6 plus 7 gives me 13. So 13 is this one. So A, B, and D goes wrong. And C is the correct answer, because they just ask you to find the number of moles of products formed. So there are 13 number of moles of products which are formed during this combustion. I hope it's understandable to all of you. Now question number 5. Separate samples, each 1 gram of the compounds listed are treated with an excess dilute acid. Which compound releases the largest amount of carbon dioxide? Okay. Okay. So first thing, if it's a group 2 carbonate, so its formula is, okay, let me do it over here. If you see, this one and this one is a group 1 carbonate, and these two are group 2 carbonate, right? So if it's a group 2 carbonate, then the equation would be this. They are reacting with an excess of dilute acid. Okay. So they didn't mention the acid. And if it's a group 2 carbonate, so I'm going to write it like this, H positive. We are going to get M2 positive, H2O, and CO2. So to balance the equation, I need to put 2 over here. Now, if there is a group 1 carbonate, then its formula is M2CO3. And I'm again going to react with the H positive. 2. I'm going to get 2 moles of metal with the +1 charge, 1 mole of water, and 1 mole of carbon dioxide. So see, if you see, in each case, 1 mole of carbonate is producing 1 mole of carbon dioxide. Is this understandable? 1 mole of a carbonate is producing 1 mole of carbon dioxide. So out of all these, who have a more number of moles will produces the more amount of carbon dioxide. Is this understandable? So we have to just work on the moles and find out whose moles are greater. Okay. So with the for the calcium carbonate, the moles can be, okay, let me remove the group number and find the moles. So for calcium carbonate, the moles would be 1.0 divided by MR of calcium carbonate, which is going to be 100.3 if I'm not wrong. Let me check it. It's 40.1 carbon. Okay, it's 100.1, not 100.4. So 100.1. Okay, can anyone calculate and tell me the moles? 1.0 over its lithium Li. So lithium is 6.9. So just calculate the MR of lithium carbonate Li2CO3. 6.9 times 2 plus, it's 48 and 1260. 2 times 6.9 plus 60. Can anyone tell me the answer, please? 13.9, 13.8, and 60. 73.8. If I'm not wrong. Here I'm getting 73.8. 1 divided by 100.1, 1 divided by 73.8. Now, 1 divided by magnesium. Magnesium is 24.3. So 24.3 and 60, carbonate is 60. So 84.3. So I will get the moles of magnesium carbonate. And over here, it's 23 or 23, 23. So 46, 46, and so it's going to be 106. So 1.0 over 106. So I think if you see this one has a smaller value, so the greater number of moles I am going to find over here. For lithium carbonate, because it's just 73.8 in the denominator, which is the smallest among them. So it means it will give me the greatest mole. So if I'm getting the greatest mole, so I will get the greatest amount of carbon dioxide over here. So my correct answer is B. A, C, and D goes wrong. So B is the correct answer. Is this understandable to all of you? Okay. Now question number 6. Which statement about Cl and double Cl bond nitrogen double bond O molecule is correct? Okay. If you see, each molecule contain one sigma and two pi bonds. If you see, it has two sigma and one pi bond, right? So this statement goes wrong. It is a non-polar molecule. No, both sides has a different element. So it's a polar molecule. So B goes wrong. It's a linear molecule. If you see nitrogen over here, there is a double bond, there is a single bond, and here nitrogen has a one lone pair as well. So see, one lone pair, two bond pairs. So whenever this is the case that there is a one lone pair and two bond pair around the central atom, so it's bent, right? It's not linear. It's non-linear. So C goes wrong. The nitrogen atom is sp2 hybridized. So if you see, there is a one pi bond in the nitrogen, right? So that's what I have told you when we were doing the P2 practice, that the carbon, nitrogen, and the oxygen, if it has a all sigma bonds, it's sp3 hybridized. If it's has a one pi bond, it's sp2 hybridized. And if it has a two pi bonds, it's sp hybridized. So yes, it's correct. So D is the correct answer. Is this clear to all of you? Now, question number 7. Okay. Which row is correct? Okay. Molecule carbon dioxide linear. Yes, very good. Carbon dioxide are linear shape. Total number of pair of electron in the valence shell of the central atom. So if you see, there is a double bond and there is a double bond. So in actual, if you see, there are four pairs of electron because there are four bonds, right? So there are four pairs of electrons. So this goes wrong, which makes A wrong. Now BF3, trigonal planar. Yes, BF3 is trigonal planar because boron is in group 13 and it has a 3 valence electron. So all of the electrons are involved in the bonding and no bond pair, no lone pair. So how many pairs of electron? So 3. If you see, yes, there are 3 pairs over here. So yes, this can be correct. Ammonia regular tetrahedral, completely wrong. I hope you all remember ammonia is trigonal planar, right? PF5. See, 5 atoms are there, so it's not octahedral. For octahedral, there must be 6 atoms around the central atom. So C and D goes wrong as well, and B is the correct answer. Okay. Now, question number 8. The volume of a vessel is 1.20 exponent minus 3 meter cube. Okay. So that is the volume. It contains pure argon at the pressure of 1 exponent 5 pascals and a temperature of 25 degrees Celsius. Okay. Under these conditions, it can be assumed that argon behaves as an ideal gas. What mass of argon does it contain? Okay. So I think we can use the formula. PV is equals to nRT, where if I keep the N as a subject, it will become PV upon RT. And if I open it N, so it is going to be mass over MR. And if I move the MR over there, so it is going to be uh, PVMR over RT. Is this understandable to all of you? Okay. Now let's start putting the values. It must be in Kelvin, so we have to add 273 over here. It is in meter cube, perfect. It is in pascals, perfect. R is, it is always provided to you at the end of the paper. So pressure is 1.00 exponent 5 times volume is 1.00 exponent 5 times volume is 1.20 exponent minus 3. MR of argon. So in periodic table, you can find the MR of argon. It's 39.9, right? It's 39.9. So times 39.9 divided by R. R is 8.31, which is always given at the end of the paper. Okay. Now, and then T, 225 plus 273 is, I think, 298. So can anyone solve it and tell me the answer, please? It is 1.93. Okay, Hassan. Okay, so it is 1.93. So it means our B option is correct. Is this understandable to all of you? Now, question number 29. Question number 9. A student makes 25 centimeter cube of 4 mole per dm cube hydrochloric acid with an equal volume of 4 mole per dm cube sodium hydroxide. Okay. So volume of acid, concentration of acid, volume of base, sorry, concentration of base and equal volume. So volume of base is also the same. The initial temperature of both solution was 15 degrees Celsius. Okay. The maximum temperature recorded was 30. So see, I can get the temperature change initially 15 and final we got 30. So 30 minus 15 is the change of positive 15 degrees, right? Okay. The heat capacity of the solution can be assumed as 4.18 joules per Kelvin per mole, and the density of this solution can be assumed as 1 gram per centimeter cube. So see, the density is 1 gram per centimeter cube. We know density is equals to mass over volume. So if I have to calculate the volume, if I have to calculate the mass, I have to, you know, uh, density times volume, right? So density is 1 gram for a per centimeter cube means for a 1 centimeter cube volume. So the mass would be also 1 gram, right? So it means that in this case, when this is the case, you must remember that 1 gram is equals to 1 centimeter cube volume. Is this understandable? Okay. Now, have a look. 25 centimeter cube HCl and 25 centimeter cube NaOH. So the total volume added is 25 plus 25, which is 50 centimeter cube. So the mass of solution is 50 grams. Is this clear? Now, if you just work out the equation of sodium hydroxide and HCl, you will find that they both react with together to form sodium hydroxide and water, and their mole ratio is going to be 1:1, isn't it? So if you see both volume are same, both concentration are same, so it means both are in the perfect ratio. So we can use the mole for any one of the reactant for the enthalpy change expression. Now, if you recall the enthalpy change expression, it is equals to delta H is equals to minus MC delta T over N times 1000, isn't it? So M is 50 times 4.18 times 15 times n times 1000. So n is the number of moles. So if I'll find the number of moles of either HCl or sodium hydroxide, it is going to be equals to its concentration, which is 4.00 times its volume, which is 25 in centimeter cube, and I have to divide it with 1000 to turn into decimeter cube. So I think I'm getting 0.1 mole, isn't it? Can anyone confirm me the number of moles? So is it 0.1? So I'm going to put a 0.1 over here. Now you will solve it and you will get the value of delta H. Can anyone confirm me what value of delta H we are getting? Yes, can anyone tell me the value of delta H? Okay, thank you, Adina. We are getting minus 31.35. So it's closer to this. So A, C, and D goes wrong, and B is the correct answer. You guys just give me a minute, please. Okay, now question number 10. Nitrogen monoxide is rapidly oxidized to nitrogen dioxide. We got the equation. Nitrogen dioxide can then demerize to form dinitrogen tetroxide. Okay, this is the equation. The delta H of formation of NO is this and NO2 is this. What is the value of a standard enthalpy change of a reaction? Shown. Okay. Okay. So let me do this. You all know that the enthalpy change of means when the elements, reacts together to form the compound. So if you see, they are asking you to calculate the enthalpy change of this reaction. Let me mark it X, right? Okay. And If I has nitrogen and oxygen over here, and they are reacting to form NO2, the enthalpy change of formation is going to be positive 91 times 2 because 2 moles of the compound are being formed. Mariam, I didn't get you what you were asking, sir. Why did H8 minus when calculating delta H? I didn't get you. What you were asking? Yes, can you clear your question? Okay, that is the part of the expression. See, whenever you are going to calculate the delta H, this is the expression that delta H is equals to negative mass times C times delta T over n times 1000, where n is the number of the moles of substance that is used, m is the mass of water, C is the specific heat capacity, delta T is the temperature, and why we are dividing it with 1000 to convert, otherwise we get the answer in joule, so convert the answer into kilojoules. So here we are using the minus, that is the part of the expression. Okay. Because it actually makes your this value correct, because if you see over here, the final temperature is what, 30 degrees Celsius, and the initial temperature is 15 degrees Celsius. So from 15 to 30, what does this mean? That the temperature is raising. And if the temperature is raised, then what type of a reaction is it? It's an exothermic reaction. So see, but the temperature change is positive. So this negative sign always makes your delta H sign actually correct. For example, for an endothermic reaction, for delta T, over here, instead of positive, you always get a negative value over here. So when you put that negative value over here, so this minus and this negative makes that value positive. So that is the part of the expression, okay? Okay. So now another thing, if you see, these two elements join with each other to form a NO2 as well. And that, for that, they have given you this, that it's positive 3, positive 34, right? Now see, when this NO2 reacts for to form N2O4, we get this energy changes there. So it means it is going to further react and forming this. And for that, the energy change is minus 58. Now, if you see, the reaction is heading in a by two ways. One is this way and ending up at N2O4, and the other one is this way. So if I make the mathematical expression, it is going to be 2 times positive 91 plus x is equals to, okay, here also I need 2 because for this 2 moles are needed, right? Twice. So 2 times positive 34 and plus minus 58. So if I x, so x is going to be 2 times 34 is going to be 64. So plus minus minus makes it 58 and 180, 182 minus 182. So x is going to be, can anyone calculate and tell me the answer, please? 64 minus 58. 2 times, okay, sorry, it's 68 if you see. Now 2 times 34 is 68. So 68 minus 58, 10, 10 minus 182. So I'm going to get minus 172, right? So D is the correct answer. A, B, and C are the wrong ones. Is this clear? Okay. Now question number 11. LiLH4 contain ALH4 negative ions in which aluminum has an oxidation state of +3. LiLH4 reacts with water as shown. Okay. So it is still +3 and it is +3. It is +1, it is +1. It is +1 and it's 0. Okay, it's -1 as well. Okay. In this reaction, each of 4 water molecules produces 1 hydroxide ion. It does this by losing 1 hydrogen ion, which reacts with LiLH4. Okay. Which changes in oxidation number can occurs in this reaction? Aluminum increases by 1 and hydrogen decreases by 1. So aluminum increases by 1 makes it wrong. Hydrogen decreases by 2. Hydrogen is -1 to 0 and +1 to 0. So no. Hydrogen increases by 1 and also decreases by 1. Yes. Oxygen decreases by 1. No, there is no change in oxygen. So only C is correct because we are observing that hydrogen has a -1 and hydrogen has a +1. So hydrogen oxidation number is decreasing by 1 and increasing by 1. Yes, Ashal, you want what you want? You want which working? This one? Okay. Now see, if you see, they are asking you to calculate the enthalpy change for this reaction. So I have put it this reaction over here. They have given you the enthalpy change of formation of NO. So whenever the formation is there, it means when the elements turns into compound, that is enthalpy change of formation, then the elements turns into 1 mole of a compound. Okay. So if you see, here we have our elements, and these elements are forming this compound. So NO. But how many moles of compound are being formed? 2 moles of compound are being formed. So that's why I put a 2 over here. So see, this reaction is headed in this direction. And then this NO reacts with oxygen to form N2O4, right? And for that, I have to find the X. So it means that the one part of the expression would be 2 times 91 plus X, because this happens and after this happens. Is this clear, Ashok? Okay. Now, on the other side, I am getting N2O4. But if you see that N2O4 is also prepared from NO2, right? And I am given with the formation of NO2. So what I did, I assumed that these elements first turned into NO2. So its formation is given. So this would be this. And then this NO2 is further turning into N2O4, which is this equation, and its enthalpy change is given, which is this. So see, first step and the second step. So on the other side of the is equals to, we got these enthalpy values. Now I have to make the find the X. So I'll keep the X as a subject and move all of the other values on the opposite side, and we will get the answer. Is this clear, Ashil? Okay. Now question number 12. The vanadium salt VOSO4 is soluble in water and reacts readily with powdered manganese in dilute sulfuric acid. The equation for the reaction is shown. Which statement about the reaction is correct? Hydrogen is oxidized in this reaction. Okay. If you see, hydrogen over here has a +1 and hydrogen over here has a +1. So no, it's completely wrong. There is no change in the oxidation number of hydrogen. Manganese is the reducing agent. So reducing agent is the one which oxidized itself, right? So if you look over here, manganese is 0 and over here it is +2. So yeah, it is undergoing oxidation. So it can be a reducing agent. That statement is correct. But let's assure the rest of the one. Sulfuric acid is an oxidizing agent. So oxidizing agent is the one which is reduced. So its sulfur is +4 and oxygen is -2. So hydrogen is, there is no change in hydrogen. Sulfur is still +6 and the oxygen is -2. So none of the element from the sulfuric acid oxidation number is changing. So it's not acting as an oxidizing agent, neither reducing agent. I hope it's clear to all of you. Now, the oxidation state of vanadium changes from +5 to +3. Let's have a look. If you see, it's all over is -2. And this all over is then +2. So vanadium is going to have a +4 oxidation number because oxygen has a -2. So we are going to change net charge of +2. And over here, If you see, so it's +4. And over here, it's -2 times 3. So it means +3, 2. So see, it's changing from +4 to +3, not +5 to +3. That makes D wrong. Okay. So we are left with only B, and we have already figured out, but we are assuring that rest of the ones are wrong. So B is the correct answer. Okay. Now question number 13. In which equilibrium will an increase in pressure at a constant temperature increases the yield of the product on the right hand side? So it means increase in pressure, yield of it's only when the product side is only possible when the product side has less moles of gases. So if you see here where there is a 1 mole of a gas and here there is none. So product side has a more moles of a gas. So A goes wrong. Then if you see there are 5 moles of gases over here and over here there are 4 moles of gases. So that can be a correct answer. 2 moles and 2 moles goes wrong. 4 moles and 4 moles equal moles, so it goes wrong as well. So B is the answer because in B there are 4 moles on the product side, so and 5 moles on the reactant side. So there might, so this is the one where we increase the pressure, we will get the more quantity of uh, product. Okay, I'm going to keep the class for today till here, and from here onward we will continue tomorrow. And I think I might keep yesterday tomorrow's class at 7:40 p.m. PST. Okay, let's see. So due to some issues, I can't continue the class for long today. So we'll continue tomorrow, inshallah. So okay, here everyone. Goodbye and Allah Hafiz.